Welcome to Data Science Perspectives. This series focuses on analytics and data science professionals from across industry to learn about how their career unfolded, what skills they look for when hiring, and what trends they think are coming next. I'm your host, Bill Franks. Let's get to it. Welcome to this episode of Data Science Perspectives. I'm your host, Bill Franks. Today, I'm going to be joined by Khalifeh Al Jadda from a small home improvement company you may have heard about here in Atlanta named the Home Depot. I first met Khalifeh a number of years back, actually, as part of my affiliation with Kennesaw State when we were both providing some external support to the data science analytics programs here. At the Home Depot, he oversees a range of their core analytical functions, including recommendations, search, and visual AI. And what ties all of his team's initiatives together is that they're aimed at providing a more personalized and relevant experience for the Home Depot customers. Now, as we're going to talk with Khalifeh about, in his spare time, he founded the very successful Southern Data Science Conference back in 2016. Each year, that show has been bringing together a lot of practitioners from around industry to talk about what they're doing in data science. He also co-founded ATLytics, which is a nonprofit oriented at doing data science and analytics for community service purposes. There's a lot of activities there. He's been in Georgia for more than a decade and actually got his PhD in computer science from University of Georgia. With that, let's welcome Khalifeh to the show. Welcome to this episode of Data Science Perspectives. Today, as you know, we're lucky enough to have Khalifeh Al Jadda from Home Depot. Khalifeh, welcome to the show.
Thank you. Thanks for having me, Ben.
You know, it's interesting. Everyone comes into analytics and data science from some different perspective and for some different reason. What initially drew you into this entire world of analytics and data science?
Yeah, it's an interesting journey. So it actually goes back to 2005 when I did my master's degree. And at that point, it wasn't called data science. It was called data mining. So at that point, in my master's thesis, I did work on improving web clusters quality using the user browsing time or implicit feedback. So it was an interesting problem where we tried to see, can we improve the search results by basically tracking the customers' engagement and interaction with the results that they see on the results page. And then after that, I just got hooked into this thing called data mining. And when I decided to do my PhD, I also chose to do my PhD in the same field. And during my PhD, the data science became really like the hot topic in the academia and industry. And it was the right time, I guess, to join the data science and analytics community. So I did my PhD thesis as well on the topic, which was scaling up the machine learning algorithms to handle big data. Because at that point, Hadoop came out, and it was like the next big thing, and everyone was talking about how to adjust or how to let's say run the traditional machine learning algorithms on big data using Hadoop with a MapReduce thing. So I did my PhD on that topic and got into the industry and started working on data science roles from the day one since I hit the industry back in 2014. So that's how I get into the data science, and I'm excited that I am in the data science field and in this great community. So, yep.
You know, it's funny you mentioned Hadoop. It's hard to think of a technology trend that rose as fast and fell as fast and far as Hadoop did. There were a few years there where it was the next thing, and by the time all the companies actually got it in place, it was sort of over. So
exactly.
So
yeah,
one
thing
it
was fun.
So how did you end up? You come out with a PhD. What led you to industry, and how'd you unfold your career and end up at the Home Depot?
Yeah, so during my PhD, exactly in 2013, I got an internship with a company called Career Builder. So Career Builder is one of the largest job board in the US, and at that point, since we're talking about Hadoop, at that point they started a Hadoop cluster on-prem. and they had like 20 years worth of data stored in that Hadoop cluster, and they did not have anyone who actually knows how to use that Hadoop thing at that point, right? So they were looking for someone who can join as an intern to start looking into the data they have in Hadoop and see how they can leverage that data to basically get some insights and value out of it. And so I got hired as a PhD intern. At that point, there wasn't even a title data scientist in the company, so they hired me as software engineering intern. But basically, my mission was go into this thing called Hadoop and let's see what can we get out of it. The interesting thing is, by the end of that internship, I was really able to leveraging the power of the big data to extract lots of insights, which kind of formed the foundation of the semantic search engine which the company built afterwards. So I was able to dig into the search logs for the last 20 years and find, patterns in the search logs. When people search for this, they also search for that. And that led us to identify the semantically related terms, which again, was the foundational work for the semantic search engine, which we later built at the company. So from that internship, I came back in 2014 as for the second internship term, and then I got the full-time offer from the company. I was very much interested in the work that we were doing there. When you came from research labs in academia to the industry, and you got impressed with the scale of the data that they have and the computation power that they have. So I decided to join them full-time. And it started from there. So I started with the search and recommendation data science team within Career Builder. As I said, our mission was to build the first semantic search engine for the company. I did that work, and then after that, I got promoted to lead the search and recommendation data science team. And we completed the work on the semantic search engine. It was rolled out for the B2B side of the business. And then after that, I started working with the team on the AI-based recommendation engine for the B2C side, which serves millions of job seekers, as you know. And after completing that project, I got an offer from Home Depot to join as senior manager of the core recommendation team. At that point, Home Depot was building the recommendation team in-house to move the recommendation engine to be in-house because it wasn't powered by in-house. So joined Home Depot back in 2018 as senior manager of the core recommendation team. We did a great job, amazing job there. Very interesting, when you move from recruiting domain to the e-commerce. Actually, it is such a move. It's a big move. The challenges are much bigger over there. The scale of data is much bigger, and the customers that you serve on day-to-day basis absolutely much bigger. When you talk about the largest home improvement company in the world, Home Depot. So after almost 2 years with Home Depot, I got promoted to the director of data science, and right now I actually oversee the search data science, recommendation data science, visual AI, and search and recommendation insights teams.
So, one thing you mentioned, Khalifeh, I was just going to comment on before my next question is, I found it entertaining when you mentioned about being hired because the company had implemented Hadoop and they didn't know how to get anything out of it. In my years in technology, I always find it surprising how many companies chase a new technology and implement it and then realize, okay, now we don't actually know what we're going to do with it or how to do it. But it happens everywhere. But you talked about scale. Obviously, Home Depot, when you talk about scale, has massive scale. So how challenging is that for you and your team as you attempt to do what you're tasked with?
Oh boy, let me tell you, it is challenging. Every time a new data scientist joins the team, the first thing we tell that data scientist is, keep in mind when you design any model that it needs to scale up to serve millions of customers in production. So if it works on a toy data set or on a small data set in your local dev environment, that's not the end of the story, because if it doesn't scale up well in production, then it's not going to be useful. So we actually usually have to develop our models in cloud. We are a big shop, a big Google Cloud platform shop. So we usually develop our models in cloud. As I said, our data scientists tend to develop in the local environment, in their laptops, local machines. But then we had to face lots of challenges when we try to deploy their models and their solutions into production. And that's why we switched now to develop actually in cloud. And also using like usually the regular SQL or PySQL doesn't work. So they also have to start using PySpark. So most of those data preparation and SQL stuff happen on Spark because, again, of the scale of the data that we're talking about. So it is a challenging, but that's the fun part in the data science, right? Data science is all about processing massive data, and as much data you can access, as much insights you can extract, and better prediction you can make. So it is challenging, but on the other hand, it is actually helping us a lot, making better models and making better predictions and extracting more insights. So it is kind of it's that balance where you face the challenge, but we have the infrastructure that helps us to tackle that challenge. We have the computation power to tackle that challenge. But on the other hand, the outcome or the return of investment of your time and effort, absolutely worth it.
Yeah, it's funny. I think that one of the biggest trends around the rise of big data and data science is that scale issue. In my book, The Analytics Revolution, talked about the very challenge you're discussing, which is it really forced people to start to consider not just the theoretical power of a model they might build, but how feasible it actually is to capture that theoretical value. And you often have to make some trade-offs of less theoretical value because you can actually achieve it. It's better than having some elegant approach that just won't scale and in effect then has zero value no matter what its theoretical value is.
Absolutely. And that trade-off actually is something that we deal with in our day-to-day job. As you just said, like sometimes simpler model that can scale up well in production is more preferred than more complicated, sophisticated, elegant models, but it will not scale up in production, right? So that trade-off is something we deal with in our day-to-day job every day.
Yeah, and it's not necessarily popular amongst the hardcore data scientists, but in fact, in my mind, it's not only just about the scale. Oftentimes, those more simple, less complex and elegant models actually perform as well or better also. So it's not a pure trade-off as we've kind of discussed it. At times, it's actually a better way to go in the absolute sense anyway.
Right. I don't know if you read a paper that won actually the best paper award in the ACM Rexis 2019, I guess, yeah. And the title of the paper was, "Are we making any progress?" And in that paper, it's a very interesting paper. The authors actually proved, as you just said, that the traditional machine learning models, especially like the tree-based models and linear models, they are actually performing better than the sophisticated deep learning models in many of the recommendation tasks. And yeah, that paper was a very interesting paper. It won the best paper award. It was a comparative study between traditional simple machine learning models compared to the sophisticated deep learning models. And it proved that for many tasks, those simpler models actually outperform the deep learning models. And that's why the title was, "Are we making any progress?" Because most of the papers in the Rexis and the recent conferences focused on deep learning. And if people just looked into some of those simpler models, especially like the tree-based models, you can absolutely achieve like better results with those simpler models.
So it sounds like you're pretty busy with work, but then on the side, for some reason, you decided to start an analytics event called Southern Data Science. What led you to decide to create your own event?
That's an interesting question. I have been asked this question many times, actually. Back in 2015, when I started to speak at conferences, data science conferences, and with the industry data science conferences become really like popular. At that point, I spoke in many conferences in 2015, 2016, and the only or the common thing between those conferences was none of them took place in any of the Southeast region. None of them. Not a single one. And when I was asking the organizers, like, why, for example, don't you host it in Atlanta or in North Carolina, Charlotte or Raleigh? The answer usually, well, it is difficult to get speakers fly from West Coast to the South. We didn't know if you're going to get sponsors. We didn't know if you're going to get audience, So, with that answer from the organizers, I was motivated absolutely to do something in Atlanta in the Southeast region. Plus, most of those conferences, really, when you go to them, you struggle with the sales pitches on the stage. So you go to learn something, and it turned out that you are there to listen to sales pitches, which was also annoying. So those are like the two motivation, which is to start something in the Southeast region with high quality, where the focus is knowledge sharing and not sales pitches. So we started as DSC back in 2016, end of 2016. We hosted our first event in April 2017, and since then it's been taking place in Atlanta every year. And I can tell you, like, the community endorsed it, and we have been very lucky to have support from everyone in the community. And you spoke last year in the event, so thank you, Bill. Everyone in the community actually contributed somehow to this event. So I like to call it like the community initiative, not my initiative.
Well, I'll tell you, as someone who put in too many air miles flying around to all the usual suspect venues, it's awesome to have not just an event that is hosted in the Southeast, but one that's truly based in the Southeast. So I know, last fall I was so excited to get to just drive down the road to the event. Of course, we ended up having to go virtual at the last minute, but I'm sure at some point in the future, I'll have the pleasure of driving 20 minutes to come to Southern Data Science. So,
Right.
You've given us a lot of background on yourself. What's something that you wish someone had told you before you started working that you had to learn the hard way on the job?
If I would think about one thing, it is absolutely the storytelling and presentation skills. I wish someone really told me before getting into the data science how important is storytelling and how important is presentation skills as individual contributor and as well as a manager. So both career paths, as individual contributor and as a manager in data science, storytelling is a crucial skill. And before getting to the industry, I wasn't aware of the importance of that skill. I wasn't really prepared or trained to be a good storyteller and a good presenter. But when you get into industry, that's the first thing that hits you hard, that if you don't know how to tell a story about the data, what you learned, especially in our field, because we speak different language than the business, than the software engineers, right? So we speak different language, and then you have to be a good storyteller. So that's one thing I wish someone told me before getting into the industry, to prepare myself very well in storytelling and presentation skills.
Yeah, that's a great point, and it's a recurring theme. I know I would echo that from my own career, and many other people do as well. And I know, at least here at Kennesaw, we really are trying. Kennesaw State University, obviously, we're trying very hard to instill some of that into our students with setting up internships, doing capstone courses with real data. But even at that, the reality is a course or two. Until you really get out and experience it, it's hard to understand that importance, especially when you spend years in academic setting getting inundated with the algorithms and with the theory. So speaking of students, then, what would be advice you'd give to students as they're thinking of starting their career? Many people are graduating this spring into a rather unusual job market. What would be some advice you'd have career-wise for them?
If I would give them an advice, I would say data science is a wide spectrum, So follow your passion, and at the beginning of your career, maybe it's a good idea to be a generic kind of data scientist where you can test everything, NLP, computer vision, statistical analysis. But as you get more senior in your career, I would say pick a field or an area in this spectrum and deep dive into it and specialize in it. So become an NLP data scientist, become a computer vision data scientist, become a statistical analysis data scientist. Don't stay generic throughout your career, because that's basically not gonna make you special in anything. So if you want to start as a generic data scientist, that's good. So you can test everything, but then follow your passion and figure out where do you find yourself. Is it in the computer vision? Is it in the NLP? Is it in the statistical analysis? Is it in the data visualization, right? Pick a field, an area, and really deep dive into it and specialize into it, because that's going to make you stand out in the crowd afterwards. So that's the advice I give the students, and I give to my team as well. Whenever like we have junior data scientists join us, that's the advice I give them as well.
I guess before we run out of time, one last question for you to leave people with. As we look to the future, obviously there's a lot of things happening in the world of analytics data science today. What's a trend or two that you think are going to be worth watching in the coming 3 to 5 years?
I've seen a couple of things actually capturing momentum recently. One of them is the graph mining and graph embedding. In fact, we are investing a lot now in that. Many companies are investing in knowledge graph and graph mining and graph embeddings these days. So I think this is gonna be kind of an important and trending thing in the data science community for the coming years. The second thing is the conversational AI, especially with the advancement that we have seen with the transformers recently. I guess that's also going to be absolutely one of the trends of the data science in the coming years. So to connect the advice that I gave with the trends that we expect or predict for the coming years, I would say for the new data scientists, the newcomers to the data science domain, if you would like to specialize in something that has a future, pick one of those two things: graph mining and graph embeddings, knowledge graphs, and or the conversational AI.
Yeah, it's funny. I always think in my head, as conversational AI gets better, there's the problem on online dating services of people pretending to be who they're not to get somebody to be interested in them. I wonder how long it'll be before somebody finds out they actually fell in love with an AI chat bot that some kid at a college invented. That might even be another level of humiliating in some ways, right? But
right.
Well, hey, thank you so much for your time today. I'm sure the audience found a lot of really interesting points that you've shared, and the scale that you're doing things at the Home Depot is obviously impressive. So thanks so much for sharing your time today, Khalifeh.
Thank you, Bill. Appreciate it. Thanks for having me.